Great. So Leah will also introduce herself. She's dialing in all the way from, where are you now?
From Berlin.
From Berlin, that's great. Then we will, we have prepared some questions, of course, for the team, and I know a lot of you are here to learn about Scroll, so we want you to have an opportunity to ask questions as well at the end. Should we start? Are we starting with Leah, or are we starting with Leah? Right. So Leah, why don't you introduce yourself? Yeah.
Yeah, I wanted to sort of give a little bit of the framing, if that works. Cool. Yeah. I just briefly wanted to introduce the two of us real quick. We're Leah and Rohit, and I'm leading partnerships at Scroll. And just for a little bit of context, I have been working in this space since 2018. And before working on infrastructure, I have been working in DeFi, so more on the dApp level, and basically have been experiencing firsthand with our users together what scaling issues come with Ethereum at times. So whenever there was a spike in usage, whether it was DeFi Summer 2020 that I think we all remember, probably all farmed a little bit, or the NFT craze beginning of this year, it became really problematic for our users. And whenever the transaction cost just spiked uncontrollably, and being able to counterbalance the spikes have proved to be quite tricky. And a few years ago when we started out, the scaling landscape was a completely different picture than it is now. There were not a lot of options available, and this is very different now. And especially when it comes to zk, there have been a lot of breakthroughs recently, both in research but also in hardware, that just allowed zk rollups to enter the playing field. And maybe Rohit can also say a little bit more about himself later, but just to give some context, he is one of our engineers at Scroll, and he will be giving an overview of the Scroll architecture. And as said, he's an engineer. He works on the zkEVM team, and he designs and builds the circuits for the zkEVM architecture. What that means, he will explain. He's also not new to crypto. He has been working in the space for a while, has been working on a protocol called REN, and also contributed to a lot of other open source Ethereum projects. And maybe we can just skip to the next slide. Yeah. Just to give a little bit of a framing, sort of a few pointers that I want to give you before diving in. We'll give an overview of what Scroll is, and in one sentence, it's a native zkEVM layer 2 solution for Ethereum. And if you go to the next slide, I want to spend just 1 minute on our vision, or what things are important for us. So overall, basically, what we're working towards is to scale Ethereum, to make it faster and cheaper for users to make transactions. And there's just a few components that are important for us, or that guide, I guess, all our architecture design. And what's special or unique to Scroll is that we're working on EVM equivalence, and basically what that means is that you will have the exact same developer experience on Scroll that you have on Ethereum layer 1. Another thing that's very important to us is we care a lot about decentralization, and we're planning on achieving decentralization step by step, and that includes decentralizing all components such as our proving and sequencer network. And third, we're building in the open, and especially the zk part we have been building with the community. And I don't necessarily want to speak for Rohit, but that was one of the reasons I got really excited when I learned about Scroll, and one also a contributing factor for me to join the team is the close connection of the founding team and the engineering team to the Ethereum Foundation. Scroll has been closely developed with the PSE team from EF, and we really do share the values of open source and open innovation. And a tiny bit of housekeeping before going into the details. Maybe you can move on to the next slide. So just a quick overview of where we are. We are currently, we have a testnet out, but this is still permissioned, but very soon, in a couple of weeks, we'll be able to open it up more to the community, and we'll launch the permissionless testnet very soon. So stay tuned about updates. One thing that we're also working on is always working on new ideas, on new use cases that become feasible now on L2. And if you have ideas or want to ping pong ideas, so feel free to reach out anytime. Our contact details are at the beginning of this presentation, but maybe we can also share it afterwards in the Telegram group that we set up. On the left side, you will find the QR code or the link to the Telegram group here for Singapore. We plan on doing more of these types of events, just really, working closely together with the Ethereum community there as well. And maybe some of you might be coming to DEF CON to Bogota as well. And if yes, then please come hang out with us on Monday, the 10th. It's one day before the conference starts. We'll have a day event, Rollup Day, where we'll have speakers from the entire ecosystem. So also Optimistic Rollups will be there. Ethereum Foundation will be speaking there. And obviously, like also other zk projects. So come join us, and we'll have time for some questions later on. And yeah, then I'll just hand over to Rohit and wish everyone a good time when learning about zk stuff on a Friday evening.
Hello all. Thanks, Leah, for the introduction, and I'll move on to my first slide, which is, I mean, we all feel sorry for this user, but, and if you saw this tweet on Twitter, you'd wonder, is Ethereum broken? Because someone pays $300 for a single transaction. That's like unheard of. But if you think about the important properties that we require in a decentralized network, then firstly it's decentralization, then security, and censorship resistance. And once you focus on all these problems, then in a way you're trying to give up on scalability to some extent. And Ethereum scalability problems were based on them prioritizing two of these components, which is decentralization and security. And scalability was never really a problem they were thinking about designing a solution for early on. And why does this happen? Because every transaction is replicated across all nodes in the network. The state is replicated across the entire network. And this basically limits the transaction throughput. So whenever there's a lot of congestion in the network, someone will try to front run you and pay more, and then of course the gas fees shoot up. So what do we need? We need scalability. At the same time, we don't want to give up on security. So during the years 2019-20, there were a lot of alternate L1s that came up. There were a lot of sidechains that came up which promised lower fees, which promised lower latency, so faster transactions, a lot of throughput, but they all came with some or the other downside. For example, there were some layer ones which faced constant downtimes. There were some sidechains which relied on not necessarily a small number of validators, but let's say most of the validators were also controlled by the same entity, so there's a lot of centralization involved over there. And of course, you must have heard about so many bridge hacks that happened recently. And all of that is basically scalability, but with some downside. So we want secure scaling. And this is what led to Ethereum coming up with its rollup-centric roadmap. So you have two different types of rollups, optimistic rollups and zk rollups. We already have Optimism and Arbitrum, which are optimistic rollups, live on their mainnets as of now. But I don't think there's any zk rollup which is a general purpose zk rollup live as of now. The first zk rollup which launched on mainnet was Loopring, I guess. And Loopring is an application-specific zk rollup, which means that on this zk rollup, the only interactions you could do is basically swap assets on Loopring DEX. But then what we need is scalability through general purpose zk rollups, which means as a developer, I should be able to deploy whatever smart contract I write, be it in Solidity or Viper or any other language which Ethereum supports as of now. Both these types of rollups have some differences in how they finalize the transaction with respect to layer 1. Optimistic rollups use a delay period, and they rely on an optimistic strategy, which means that they think there will be some public user who's watching for any fraud which is happening on layer 2, and we'll give them 7 days to which is the period during which they can submit this fraud proof to layer 1, saying that, oh, I've noticed some fraud and the sequencer should be penalized for this. And there are these crypto economic ways of achieving security in this kind of setup. For zk rollups, we have a cryptographic proof, which in crypto native terminology we call them as validity proofs. So validity proof basically is a snark or a proof which says that given the starting state A and given a set of transactions that happened on layer 2, we arrive at state B, and this is a proof, a cryptographic proof that the state transition was done correctly. And once this proof is verified on layer 1, then as a layer 2 user, you are sort of sure that, okay, my transaction has been included in layer 2 and it has been confirmed and verified on layer 1, so it's finalized from perspective of layer 1. Both have different scaling potentials, and zk rollups can provide better scalability in the future as the crypto primitives improve and hardware computational efforts improve. So why are we building an EVM equivalent EVM equivalent zk rollup? I'll come to that later. But we use Ethereum as our base layer, which provides us security and data availability. And this is also the consensus layer. So whenever we post our validity proofs back to layer 1, it is on Ethereum. And Scroll is the layer 2, where you do, as a user, you do fast transactions, you get lower fees, and it's EVM equivalent because we want more developers and make life easier for users and developers, which I will go through later as well. So before I dive deeper into the different flavors of zkEVM itself, here's a small overview of what happens when you write a smart contract and how it gets compiled and executed in the EVM runtime. So there are several different high-level languages in which you can write smart contracts. The most popular is Solidity, but there are a few more like Viper, and these days there's another language which is really popular called Huff. And each of those languages have their own compilers, which are able to compile this high-level language code into EVM-compatible bytecode. So what you have at the end of this is a list of EVM opcodes, and these opcodes are basically run one by one in the EVM runtime. This is basically what happens under the hood. So zkEVM, which is a really popular word today, there are different flavors of achieving zkEVM, and there are different levels of compatibility. So the first and the sort of the loosest compatibility is language level compatibility, where you say that as a layer 2, I'm going to have a custom virtual machine, not the EVM, not the Ethereum virtual machine, My custom VM will be much more friendly to these snark proofs. So proving, verification, all of that becomes a bit easier. But I will only support certain languages, let's say Solidity, and I'll transpile that.
Hello?
Hello. Oh, yeah. And then I'll. It's downtime. and I'll transpile that Solidity code into another language, which, for example, if you've heard about Starkware, so they have this language called Cairo. So you write code in Cairo, and then Cairo gets compiled down to Cairo VM. I'll discuss that later as well. So this is language level compatibility, because you are, as a layer 2, you're allowing developers to write programs in a certain language which gets transpiled into something else, which gets compiled down into a custom VM which is not EVM. Bytecode level compatibility is where Scroll lies in, and which basically means that Scroll's zkEVM architecture is able to interpret the EVM bytecode itself directly. So we don't really limit developers to using a particular language or something, as long as your code, be it Solidity or Viper or Huff, as long as it can be compiled down to EVM bytecode, then it can be supported on Scroll. And this is a comparison of how each of these different ZK rollups are sort of, whether they are closer to Ethereum or whether they are farther apart from Ethereum in terms of compatibility. So if you look at the leftmost side, which is Starkware and ZK Sync, it comes with its own advantages. For example, the prover costs are low. But the downside is that you need developers to learn a different kind of technology. You need developers to learn how to write their programs in Cairo. You need to build certain transpilers so that Solidity code can be transpiled into their own custom VM. And as you approach closer to Ethereum, then you have bytecode level compatibility, which means that it doesn't depend how you write your code or which language you write your code in. As long as it's EVM compatible, then Scroll can support it. Polygon Hermes also lies in the same category. There are certain minute differences in how they achieve EVM compatibility, differences between Scroll and Polygon, but at the end of the day, for a developer, it would be a similar kind of experience. So I'll briefly go through the zkEVM based architecture of Scroll. So as you can see that on the layer 1 side, which is Ethereum, we have a set of contracts mainly categorized into rollup contract and bridge contract. The bridge contract is basically what a user uses to interact with when they want to bridge from Ethereum to Scroll, bridge back from Scroll to Ethereum. And the rollup contract is something that stores the layer 2 state. So for example, it'll store the state roots, and it'll also be the way to prove the validity of the validity proof. And it's also a way for users from Scroll to force exit. If they don't want to be a part of layer 2 and they want to force exit without their transaction going through layer 2 itself, then they can force exit through layer 1. All of that happens to the through the rollup contract. And it's not. Can I go down to the next slide? And so on the left side, you see the sequencer. Oh, okay. So the sequencer is a get fork, which is basically the node which, as a user, you would interact with. The sequencer is responsible for batching transactions and posting the transaction data to layer 1, and it's also responsible for then. So think about this. The sequencer is a get node there are certain differences which we have added from Get, which are basically to suit what Scroll needs. And okay, so let's say you have a Scroll block, which is a layer 2 block. That block consists of a set of transactions, and each transaction is a set of opcodes which were executed in EVM, right? So you get an entire execution trace for that block. So this execution trace would have everything like all the opcodes which were executed and one by one. And this execution trace is then sent from the sequencer. The sequencer basically schedules the roller to generate a proof for this execution trace. And the roller is composed of a lot of components. And we have a lot of sub-circuits. We have the EVM circuit, the state circuit, transaction circuit, Keccak circuit, bytecode circuit, and the roller is responsible for creating proofs for each of those circuits. So it goes through the trace, converts it into witness data for our zkEVM circuits, and generates proofs for each of those circuits. And those set of proofs then go through another circuit, which is called the aggregation circuit. And this circuit aggregates all those set of proofs into one single proof, which is the validity proof for that particular block. Once that proof reaches back to the sequencer, then it can prove that validity proof to, it can publish that validity proof to layer 1. And at that point in time, as a layer 2 user, you know that your transaction has been finalized from the perspective of layer 1. So why are we taking this approach of building a zkEVM based zk rollup? So the first and the most important benefit of our approach is that we don't want developers to spend time on moving to a different kind of infrastructure. We don't want them to spend more time on learning new things. We want scalability now, and which means we want developers to use whatever knowledge they have and implement dApps, which are probably not possible today on Ethereum because of some scalability limitations. And we want them to move and migrate seamlessly to Scroll and deploy their smart contracts. The entire circuits and proving part is quite complex. There's a lot of cryptographic moving parts that are going on around there. But we've tried to encapsulate all of that away from a user who just wants to deploy their smart contract on Scroll. At the same time, EVM has been battle tested for a long time. There are many audit firms which are well versed with the EVM, and there's a lot of fuzzing techniques, a lot of testing infrastructure which is built around that. So we know that the EVM execution model is secure, and we want to stick to it while providing scalability. So let's quickly go through where we are at the moment. We've already launched the pre-alpha testnet. On this testnet, you can basically mint certain tokens, bridge them to Scroll, and we have deployed a fork of Uniswap, where you could swap ETH to USDC, USDC to ETH, and this pre-alpha testnet already has the proving part live. So as soon as you do your transaction on layer 2 and there's a layer 2 block, then there's a validity proof which gets submitted to layer 1, which finalizes your transaction. Moving on, the next phase for us will be a more permissionless testnet, where as a developer you can deploy your own smart contracts. And the next part after that is proof outsourcing. So we want a decentralized prover network, where as a public user you could simply join the prover network, plug in your GPUs and start generating proofs, which makes the prover network decentralized. And beyond that comes our mainnet. And then there are certain more things in our roadmap, like decentralizing the sequencer itself, but that's down the line. So if you want to be a part of the pre-alpha testnet, and if you want to use it, see how the layer 2 experience feels like, and you can go to signup.scroll.io or scan this QR code and you can become a tester. You could report certain UI issues or bugs if you notice. Be a part of this community, and I think it will be a lot of fun. Next, if you want to build with us, if you want to integrate with us, if you want to build applications on top of our layer 2 solution, then you can reach out to us, and we are here to help you and work with you. And lastly, we are hiring. There are multiple open positions in the engineering department as well as other departments. Just reach out to us, and we are happy to speak to you. Oh, thank you. So if there are any questions, I'm happy to take them.
Hi, sorry, so loud. Thanks guys for coming. I think this is the first time I see this space so packed, to the rafters with this. And I was going around just now to talk to people, and many big brains in this room, right? Especially Rohit as well. Anyone has any questions for Rohit after the presentation? You first, right? Okay.
Thanks for the presentation. I got a question. You just mentioned that that there's a method to bypass to straight away send the data to the layer 1. Is that something that I misheard, or is that something you actually mentioned?
Okay, so yeah. So actually, it's a very important part of being able to call yourself a rollup.
Right.
Because it provides you censorship resistance. So let's say I'm a layer 2 solution where you're not allowed to exit via layer 1, then you're relying on me to include your transaction, right? And if I'm in control of the sequencer, and if I know your address, I can censor your transactions, which is something as a user you don't want. So because we post transaction data on layer 1, then the contract is able to verify that you have, let's say you're trying to exit the layer 2 and you have, let's say, a balance of 100. So the layer 1 contract is able to verify that you have a balance of 100. So you don't need to withdraw and exit through layer 2. That's the basic solution. You can do that. But in case you feel that your transaction is being censored, you can exit via layer 1 as well, which is a very important property for rollups. There are certain projects which call themselves rollups, but then they don't really exhibit this property.
So that's more like an escape hatch. Is that what you're trying to say?
It's an emergency exit which provides you censorship resistance guarantees.
Got it. Yeah, got it.
Thanks, Rohit. So you mentioned about decentralizing the prover and sequencer, right? How do you plan to achieve decentralization for prover, given that it requires special hardware?
Yeah, so it looks something very similar to how proof of work used to be in Ethereum, right? You have your own GPUs and you join the network and you start mining. So similarly, you would join the network and start proving instead of mining. And the way we haven't yet figured out the algorithm for randomized randomized scheduling. As of now, we are just using something very simple like a round-robin method too, because we are in the pre-alpha testnet. Scroll itself is running like 4 prover networks, 4 prover nodes. So we are using a simple round-robin method, but in the future, when it's a decentralized prover network, then we'll use something more complicated like a randomized scheduling, so that given some sort of parameters which make you a good prover or a more powerful prover or something like that, in a randomized way, you would receive tasks from the sequencer to generate proofs. Yeah.
Right. I have like 3 follow-up questions on that.
Okay.
So does you only need GPU? Secondly, does that mean, but sequencer, could it use POS? And thirdly, does it mean that currently you are running a centralized sequencer and
yeah,
prover?
so in the pre-alpha testnet, currently we run our own sequencer, we run our own provers. It's a centralized setup as of now for the pre-alpha testnet. Our goal to reach a permissionless testnet is not to fix this part as of now, because we want to support full EVM compatibility as well as smart contract deployment. So this part of decentralizing the prover and sequencer comes before the mainnet. So it's down the line after the testnet. Yeah.
Got it. Thanks.
No, thank.
Yeah. Do you need just
was there another
GPU?
question? Oh yeah. So for the prover, yes, you need a GPU. You can't do it on a CPU. Yeah, you need a GPU. In the future, there could be some hardware developments where, it's hard to come up with a very specialized hardware like an ASIC miner for this, because for ASIC miners, let's say Bitcoin, you have ASIC miners, right? It's because they do the same computation, so you can specialize the hardware for it. But let's say we have a live scroll network, and then there are certain changes in the EVM. There's a new opcode which has been added, and let's say we want to build a separate circuit for it. Then there has to be some change in the zkEVM architecture. And to incorporate those changes, you can't go and start building another specialized hardware for it. So as of now, because GPU provides general purpose programmability and scalability, like parallel computation, then as of now, GPUs are much more the right approach. In the future, that might change if we have like an approach which doesn't really change for 2 years or 3 years or something like that. People could consider building specialized hardware, but as of now, it's GPUs. Yeah.
Any more questions, guys? There we go.
How will you handle MEV at layer 2? Like, will you like split the role of sequencer with other, with other actors, like with some kind of PBS?
Okay, so with a centralized sequencer, handling MEV is not really something we can promise because it's a centralized sequencer, right? It has all the MEV. When we decentralize the network, it's still something that we are researching on. It's really in the introductory phase of research, but we are picking up some research work from the proposer builder separation model. And in case we want to decentralize, like when we decentralize the sequencer, we'll take inspiration from that research which is being done in the Ethereum space as of now, because that's also to limit MEV. Yeah.
What's your plan when you decentralize your sequencer? How many sequencers are you looking at? And then how do you like prevent the trade-off of performance and latency when you have a decentralized sequencer?
So this is something we have not really dig deeper into as of now, because as of now we are trying to achieve full compatibility with Ethereum EVM. But it's something that a couple of our researchers are working on at the moment, and I don't have a very good answer as to what heuristics we are looking at and what sort of parameters we are looking at, and what's the optimal sort of sequencer decentralization would look like. I don't have an exact answer for that because I'm not very well versed with that.
Final question.
Yeah.
Like, when will you all release metrics? Like, what is your proof generation time? What is your proof size? Right.
Okay.
Based on how many TPS, what's your verification of the L1? The cost?
So right now we have a pretty basic kind of proof generation algorithm, and it takes a little less than 1 million gas to verify on layer 1. Like the proof to be verified on layer 1, it takes less than 1 million gas. There are certain optimizations that we can do to make it more efficient so that the verification cost could go down, which is good for us. Proof generation time wise, we are right now we are running NVIDIA A10s, and it takes around, I think, around 12 minutes or something to generate proof for one block. It takes a long time, but we have certain optimizations.
One block have how many transactions?
It doesn't matter a lot how many transactions because the circuit size remains the same. So the proving time depends on the proving cost, or the proving time depends on how big your circuit is. So as long as we can fill that circuit with, let's say, 1 transaction or 5 transactions or even 100 transactions, because the circuit size doesn't change, then the proving cost also doesn't change.
The proof size?
The proof size depends on the number of columns we have in the circuit. So let's say I want to build a bigger circuit with more columns, then the proof size becomes bigger, which also takes more time to, which also takes more gas to verify. So the way we build our circuits is to optimize for this itself. So I wouldn't use, let's say, 50 or 100 columns if I can achieve that same sort of constraints using 10 columns, so that I'm limiting the proof generation time as well. So yeah.
Anyone else has any questions? Oh, okay.
I noticed that you mentioned that the proof size increases with more transactions. So I'm really curious, like what proving systems are you guys using?
Can you repeat that?
What proving systems is what proving system is Scroll based on?
Oh, Scroll uses Halo 2.
Oh, so that means there's some recursiveness going on over there?
Yeah, so Halo 2, Scroll's zkEVM is based on Halo 2, and we've built our own aggregation circuit which makes use of recursive snarks.
Is it the EF's version of Halo 2, or is it like the original Zcash versions of Halo 2?
No, it's the PSE version of Halo 2.
Yeah,
So
got it.
because we work in collaboration with the privacy scalability.
Oh, the one that uses Kate? The one that uses KZG instead of like the bulletproof scheme?
Yeah, so we use the polynomial commitment scheme, which is the Kate polynomial commitment.
Got it, thank you.
Yeah.
Any more questions? Anyone from the back? Any questions there or the side? If not, I think thank you, Rohit. Thanks for the presentation.
Thank you.
Yeah. So before you leave your seats, right? I mean, those who just came in, there's some seats here if you want to fill them up, because I think there'll be a demonstration by Spartan Labs team after this. Just some introduction, right? My name is Derek, right, and I head the research unit at Spartan Labs. Today we have here the Spartan Labs tech team as well, who are going to do a demonstration, right, of how we can implement ZK into SBTs, right? So Chin Hao and Yong Kang, you want to take it away? Once again, there are seats here if you want to populate it. Yeah.
Hi everyone, so I'm Jun Hao and I lead all things tech in Spartan. So, our mission at Spartan has always been to help the best entrepreneurs and builders thrive in the space. And that also means inspiring builders such as yourself towards onboarding the next billion users into Web3. So that also means that recently we have been pushing out thought leadership in the Web3 space, tech thought leadership. And one distinct trait of our work is that when we talk about ideas, we make sure that we come with actual working code, actual working demos, or actual working proof of concepts, right? We want to show and inspire all of you, builders, entrepreneurs, that some of these technology like zero knowledge is ready and things can be built on top of it. So if you look at the screen, we talk about things like NFT smart contract vesting. So over here, we apply the concept of token vesting, whether it's linear, exponential, interval vesting, and we apply them onto NFTs. There's a lot of other information on the article, so I encourage you to go and read it when you have time. Secondly, we also talk about soulbound tokens. Can we go on to the construction? So we talk about soulbound tokens as well, and we dive into what the vision of what soulbound tokens look like to Spartans, the kind of composability that it allows in the Web3 space. And we also talk about, if we do the kind of naive implementations, the kind of issues that we can have, whether it's privacy related, or we kind of push the computation on-chain and you have very high gas costs. So some of these things, if it's too naive, we can't actually use them in production. So it's quite timely today that we have a builders focused event on zero knowledge, because the next few parts of our tech thought leadership is exactly that, applying zero knowledge onto soulbound tokens so that we enable privacy-enabled composability in the DeFi space. So we are actually 2 weeks away from pushing this out into public. So the demo that you're about to see is live. To thank you all for coming here today. It's Friday night and you're spending your Friday night with us. So if there's any small little bugs and all that, please forgive us, all right? Okay, so I would like to give the airtime to Yongkang. Yongkang here is our resident zk expert at Spartan, so it's going to show you a demo on applying zero knowledge onto soulbound tokens. Yongkang?
Hi everyone, I'm Yongkang. So actually this is a very trivial example of showing how we can apply zero knowledge to soulbound token. So as you guys might know, soulbound token is a concept where you want to have some data about the user on-chain, but you want to mask that if it's a sensitive information, and that's where zero knowledge is very, very important. So in this example, assume that is a under-collateralized lending protocol that has ability to KYC a user's credit score and have them posted on-chain. But as we know, we don't want credit score to be publicly viewable on-chain because that can pose a lot of risk, doxing, and things like that. So for instance, that's why we will use the concept of zero knowledge to generate a proof, and because everyone can easily verify the proof, you can verify if this user has above X amount of credit score. Hi guys, welcome to the zero knowledge soulbound token mint demo by Spartan Labs. So what this demo does is essentially show you how soulbound token can be integrated with zero knowledge tech. So we start with connecting our wallets. So once your wallet is connected, you can go ahead and get some testnet ETH from the gold leaf faucet. Next, you can select a credit score. This is arbitrary representative of a protocol issuing credit score, but having zk proof to mask the actual value of the credit score. So after you select a credit score, you can go ahead and mint it, and the mint window will pop up. So once you accepted the minting will continue. But in this case, the credit score will be used to generate a proof, and this proof will be attached to your soulbound token. Nobody else except for yourself know what the actual value of the credit score is. There is almost no way to deconstruct it. And you can view the details of your minted soulbound token over here. And if you would like to verify whether someone or address has a soulbound token that fulfills a certain criteria, for in this case, where their credit score is above 5, you can go ahead and input the address as here. So in this case, I just minted a soulbound token, and I can verify that, hey, my credit score does not have a value above 5, even though the value is not known to the public. But if I were to use a different address that has minted with a credit score above 5, then this will be a success indication. So to show this in action, I will now change my wallet. In this case, it's a fresh wallet, and I'll mint with a credit score of 12. And once this transaction is minted, you can see the different details on the soulbound token as well. And right now, this is the address that I minted with the credit score above 5. It is almost impossible to find out what exactly is the data behind this, but anyone can verify and see that the address has a soulbound token with a credit score above 5. So in this context, it may be a very trivial example, but this can be used in other contexts, like proving an attribute about yourself without revealing what it is, and the potential are limitless. Thank you.
All right, thank you for Yongkang for the demo. Right. So as you can imagine, if we take this concept a bit further, there's a lot more composability that we can build into the Web3 space. So I hope that inspires you all, right? Anyway, also, it's a live demo, so I think it's a bit stressed right now. Okay, so I guess I'm just like kind of hodling everybody back from like food, drinks, and networking, right? So I'm just gonna wrap up really quickly. Just three things. First, if you're interested to hear more from us about these kind of thoughts that we have in the space and all, please follow us on Twitter and check out our newest website on Spartan Group. And secondly, if you have any interesting topics that you'd like to collaborate with us on tech thought leadership, and if you just have any interesting pressing concerns in the space that you'd like to hear our opinions on, feel free to approach anyone here, because you see a lot of people in like Spartan apparels that are Spartan Group team. Just talk to us and suggest them to us. And finally, if you have interest in using any of our code, like you want to discuss with us about our open source code, you want to extend them, you want to use them, they are MIT open source, so you can feel free to just use them. And if you'd like to geek out with any of our technical team, I'm going to introduce you to the Spartan Group technical team. Come and geek out with us, all right? So that's Yong Kang, he just gave us the tech demo. Tristan, Dominic, hey, Dominic's over there in a green shirt. All right, from the tech team can geek out with us. And Tristan over there, Tristan, can you raise your hand? The white shirt over there, he's raising his hand. Right, so if you want to talk about anything tech-related, zero knowledge with us, feel free to as well. All right, how are we gonna wrap up? Someone wants to give a closing speech? Hey, Sean. Sorry, not prepared for this.
Yeah, I think like what Jin Hao mentioned, we don't hold you guys up anymore. But just one last word, I think this is really the first ever builder networking event that we want to set for Spartan Group itself. Right, going forward, we will have more events happening within this compound or at other events spaces itself. So do follow us on Twitter, do follow us on any social media accounts, and yeah, hope to see you guys again. Thank you.